Hello everyone, welcome to Wi-Fi Learn. We are seeing the circuit theory subject and we have covered some topics regarding equivalent resistance, Ohm's law, voltage division and current division. Let's see some problems regarding those topics. In this video, we can see problems in equivalent resistance. The book I refer for problems is Electrical Circuit in Some series written by Mahmoud Navi and Joseph A. Administer. Let's move on to the problems. See, in this problem, the equivalent resistance of 3 resistors in series of 750 ohms. 2 resistors are 40 and 410 ohms. What must be the resistance of the third resistor? See, in this question, they have given that 3 resistors are connected in series. First, we have to draw the diagram. How does the resistance would be connected? See, 3 resistors are connected in series. So, 1, 2 and 3 resistors, and they have given the equivalent resistance of 3 resistors as 750. So, R equivalent would be of 750 ohms. 2 resistors are given as 40 and 410. Let's take any 2 resistors, this as 40 ohms and this as 410 ohms. And what will be the third resistor? Assume this as a third resistor. We all know that if the resistance are connected in series, then the total resistance or equivalent resistance can be given by summing of all the resistance. So, R1 plus R2 plus R3. Just assume this as R1, R2 and R3. If you sum up, we can get the equivalent resistance. Here they have given the equivalent resistance as 750 ohms and they have given R1 and R2 as 40 plus R2 is 410 and they have asked the R3. Value of R3 resistance by doing some arithmetic calculations will get the value of R3. So the value of R3 is 300. It's a simple problem. Finding equivalent resistance in series connection. In this problem, they have given obtain equivalent resistance of 2 subdivisions are there. First subdivision is if 2 resistors of 60 ohms resistance are connected in parallel. Second subdivision is 3 resistance 60 ohms resistance are connected in parallel. It is the problem of finding the equivalent resistance in parallel connections. So we can draw the circuit diagram and we can find the equivalent resistance. It's very simple problem. 2 resistors of 60 ohms are connected in parallel. Okay. So, A subdivisions is 2 resistors. 2 resistors in the sense 2 resistors each of 60. Both are of 60 ohms. We have to find the R equivalent if 2 resistors are connected. If 2 resistors are connected in parallel, then equivalent resistance formula is R equivalent is equal to R1 R2 divided by R1 plus R2. Give the formula as 1 by R equivalent is equal to 1 by R1 plus 1 by R2. This is the reduced form of this format. So, we can find the R equivalent as R equivalent is equal to 60 into 60 divided by 60 plus 60. We will get the value as 3600 divided by 120. So, we will get the value as 30 ohms. 30 ohms. If 2 resistors are connected in parallel, then the R equivalent is 30 ohms. In second subdivision, they have asked if 3 resistors are connected in parallel. In that case, connect 3 resistors in parallel, each of same value 60, 60 and 60. There we have to find the R equivalent value. So, R equivalent formula is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, the formula will be changed as taking LCM R1, R2, R3 will get R2, R3 plus R3, R1 plus R1, R2. So, the value of R1, R2, R3 is 60 ohms. Each are of same values. Doing that mathematical calculations, we will get the value as 1 by 60 plus 1 by 60. 1 by 60 is equal to 1 by R equivalent. We will get the value of R equivalent is equal to 20 ohms. So, we can make an identity that if an identical resistors are connected in parallel of n number of times, If identical resistors are connected in parallel of n number of times, then R equivalent can be given by R resistors divided by number of times in which the resistors are connected in parallel. It is a shortcut of finding the R equivalent when R is same, when R is equal and they are connected in parallel. In this example, R is equal to 60 ohms and it is same for 3 resistors connected in parallel. So, we can find as substitute the value of R is equal to 60 ohms. How many times it has been connected in parallel? It is connected 3 times, 1, 2 and 3. 3 resistors are connected in parallel with same resistance value. So, we can put the n value as 3. So, we can find the value of R equivalent is equal to 20 ohm. Instead of doing such a long procedure, remember this shortcut to find the R equivalent if R is identical and it is connected in parallel for n number of times. This is a formula. It is easy also to find the R equivalent value. See, in this problem, they have asked us to find the R equivalent. I have given the circuit also. It is a combination of series as well as parallel resistance which are connected in the circuit. So, we can reduce by step procedure. It is very easy also. See, first take this branch. And here this 20 ohms and 20 ohms are connected in parallel. We can reduce that first. If parallel resistance are connected, then we have to do a formula that 1 by R equivalent is equal to 1 by R1 plus 1 by R2, or we can use the shortcut also which I have given in last problem. So, R equivalent will be equal to R divided by N if the value of R is same for all the resistance which are connected in parallel. Here R is equal to 20 ohms connected twice. So, we can write as 20 divided by 2. So, R equivalent in this branch would be equal to 10 ohms. So, we can reduce the circuit further as after reducing this parallel circuit, we will get a R equivalent as 10 ohm and again 10 ohms is connected in series and this 20 ohms is connected. So, we have to reduce the circuit from right to left. See, here 10 ohms and 20 ohms are connected in series. We will get the value as 10 plus 10. For series resistance, R equivalent is equal to summing of R1 plus R2, summing of the resistance. So, 10 plus 10 will get us 20 ohms. So, R equivalent of the series resistance is 20 ohms. Your further circuit will be reduced into, are connected like this. See, if you see this, these resistors are connected in parallel, right? One end of this resistor and other end of this resistor are connected to a common point and remaining two ends are connected to some other common point. Forms a parallel connection. For parallel connection, R equivalent would be equal to 1 by R1 plus 1 by R2. Here both the resistance are of same value. We can use this formula to find. It is easy. So, R equivalent would be equal to R divided by N. Your value of R is 20 and number of times connected is twice. So, 2 we will get the R equivalent value as 10 ohms. So, the value of R equivalent is equal to 10 ohms for this circuit. See, in this problem, find the R equivalent if Rx is varied as. They have given some subdivisions, that is resistance is variable as when Rx is equal to infinity, when Rx is equal to 0 and Rx equal to 5 ohms. We have to find the equivalent resistance of this circuit for these cases if Rx is varied. We can solve one by one, it is very easy. Okay. In first subdivision, they have given that Rx is equal to infinity. Infinity means Rx value has a maximum value. Resistance will resist the flow of current, right? If Rx is infinity, that is resistance is high means that is the current won't flow in that path. If resistance is infinite means then the current won't flow. Resistance will resist the flow of current, right? So, in that case the current won't flow in the circuit. When does the current won't flow? If the circuit is open circuited. If it is closed circuit, then current has a path to move. If the circuit is open circuit, then the current does not have the path to flow. At that case, the current would be equal to 0. And another condition also where the current would be equal to 0 if the resistance is higher. So, we can represent the circuit as open circuit in Rx if resistance is infinite. So, Rx is equal to infinite, your current won't flow here. Now we can find these two resistors are connected in series, 16 ohms and 20 ohms. This resistance has maximum value that the current won't flow. So this circuit will be finished by finding this resistance alone. So R equivalent would be both the resistors are connected in series. For finding the series resistance, it is a summation of resistance that is present in the circuit. So 16 plus 20 ohms will get the value as R equivalent is equal to 36 ohm if Rx is infinite. When does the current will be 0? If the circuit is open circuited, or in the case of resistance is higher. In second subdivision, your Rx value is 0. If resistance is 0, then current will be maximum, that is we can represent current as infinite. Resistance will resist the flow of current. Here resistivity is 0. If here resistance is 0, so current will be maximum. You can represent the circuit as short circuit. Here the circuit is shorted, that Rx is equal to 0. Here 20 ohms, 16 ohms are connected. We have to find the R equivalent here. See, in this the circuit is shorted. If you apply the supply, the current will flow from here and it won't take a path here because it has a low resistance path and it will flow here and the current won't flow in this path. Because here the resistance is 0, the current will take the path which has a low resistance path. It will flow in that path only. So the whole current will flow through this path. So that where the resistance is 0, this resistance would not have any value. Whether it is connected or not connected, it doesn't have any value and the current won't flow in this path. Why? Because here the resistance is 0, the current will take the low resistive path. So the current will flows here and this resistance has no value. So if you find the equivalent resistance for this circuit, your equivalent resistance will be only 16 ohms. This resistance has no value if the path is shorted. Since the current would take the low resistive path to flow, this path will not be valid since current takes low resistive path. Okay, this resistance, so 20 ohms resistance will not be valid to take a R equivalent value to calculate. In last subdivision, Rx is equal to 5 ohms. Here the Rx has some value. Rx is 5 ohms and this is 20 ohms and this is 16 ohms. You have to find the R equivalent. 20 and 5 are connected in parallel. So if you find the R equivalent of the parallel resistance, so 20 into 5 divided by 20 plus 5 will get 20 into 5 divided by 25. Doing mathematical calculation, we will get a value of R equivalent is equal to 4 ohms, this parallel part only. Now the circuit will converted as 16 ohms and 4 ohms are connected in series. So if you find the R equivalent now, 16 and 4 are connected in series. So R equivalent is sum of those resistance. So 16 plus 4 will get us 20 ohm. Or R equivalent value is 20 ohm for this. Rx is equal to 5 ohms. So when resistance is infinite, your current would be 0. R equivalent value would be 36 ohms. Your resistance is 0, current would be infinity. This resistance won't be valid and current won't flow in this path. R equivalent would be 16 ohms. For Rx is equal to 5 ohms, your total resistance value is 20 ohms.